Yeah, hi everyone. Very good evening to all of you and welcome to the all learners, those who enrolled the PDSA course in this term. Before starting this open session, first for the week one, we want to introduce ourselves. So all three instructors are here. So myself is Atul Pratap Singh and I am the one of the instructor of this PDSA course. So before this term, so I have already worked in the Python course and in the one term, and after that we have completed 3 terms in the PDSA, and so this is the 4th term. And also in this term, I am also working in the MED1, Modern Application Development 1. So for about this course, basically the week 1 have already released. So what we will learn in this course, so basically there are 2 components we will learn. So first is data structure and second is algorithms. So here we will learn the basic data structures like Python data structure, stack, queue, list, graph. And apart from that, we will also learn the different type of algorithm design techniques in this course. So as you know, so why this subject is important and why the efficiency is important. Okay, so as sir have already discussed in the lectures, if you have already watched the first week videos, so why the efficiency is important in the real-time problems. So why we are learning this subject. And so first thing is the efficiency, as you know, and second thing is that this subject is very important for the placement purpose. So placement purpose, when you work in the industrial level and any production development company, so these data structure things are very important because every company wants that skills. The programmer should be efficient and the code developed by the programmer should be efficient. So because of that, they want these skills at the entry process. Apart from that, we have another instructor in this meeting, Bhaskar Banerjee and Danya ma'am. And one more instructor we have, Omkar Joshi, and that will he will provide the support in the code shape things. And another thing, so Bhaskar, now you can continue.
Yeah. Okay. Thank you all. So am I audible, by the way?
Yes, Bhaskar.
Yeah. Okay. So hello all. My name is Bhaskar Banerjee, and as already introduced by Atul, that I am one of the instructor of this course. So basic introduction, I think Atul has given. He has introduced us. So I'm not going into our details anymore. So we would continue the session, and before that, I would actually ask Danya ma'am to give her intro. Then we would continue with our session today. Yeah, ma'am, you can go ahead.
Yeah. Thanks, Bhaskar. So I just just finished another live session. So yeah, and now I'm sorry, but I'm unable to switch on the video for today. So sorry about that. So yeah, people have done maybe Java or some other DBMS course, maybe might have heard of, maybe know me. So I've been an instructor for DBMS and Java, and this time I'm actually been working as an instructor for the PDSA course. So a little bit of background about myself. I did my PhD from IIT, and so hopefully we can have a very constructive interaction during the live session. So we request you to be as interactive as possible, so that in the process of teaching we also learn, and every session that we have with you is a learning process, right? Because people from all kinds of backgrounds join this, and even the very basic things which we sometimes take for granted, comes as a doubt, and we start looking deeper into it and try to understand more things about it. So yeah, let's all keep it more interactive and fun. Okay, so all the best to all of you. Yeah, Bhaskar, that's it.
Okay. Thank you, ma'am. Thanks for that. Okay, so let's start today's session then. And so first of all, as ma'am has already mentioned, that we would be interacting a lot. That's what, at least that is what we expect, all of you. So in this course, algorithms, the very essence of this course is to think about problems. obviously at the end of the day, we have some already, we have some solution techniques to solve a problem, right? And that's what we would do. But we don't want to just directly go into those solutions directly, how you actually apply algorithm to solve a problem. Okay, what is the meaning of algorithm and all those things we would briefly discuss as a part of this session, because this session is mostly your Python recap, right? The first thing. So if you have any doubt, it's okay. But mostly we would discuss about the main, the intention of this course, how you should go forward in this course, and the importance of this course. Okay, and also some technical topics we would discuss, which are not very specific to any week, but it's kind of an intro to the overall thing. Okay, so before moving into that, I was just telling that we have some solutions for each and every kind of problem, not each and every, most of the basic. We have classified some basic problems that we see in real life, and these problems, when I say problems, these are just, it's not something very, you need some background to understand those kind of problems. No, it's just a comprehension kind of problem. You have been given a real life scenario and you kind of have to optimize something. That can be minimization, that can be maximization, that can be finding a solution to anything. But there are some problems and you have to solve it. There is no very difficult prerequisite or some lot of things required. Only thing is you have to be, a bit active to think. To every time you have to think, every time you have to question things. So what I was saying is, most of the problems that we will discuss, they have some specific solution to them, which are the till now obtained the most efficient algorithm solution to those problems. But we don't want to directly get into them as a part of these live sessions. Okay, obviously all of you understand the constraints of the lectures, because the lectures professor, they have to deliver it in a specific amount of time. So we cannot expect that incremental growth while discussing an algorithm, that okay, this is at this level, this algorithm is there, then let us try to improve it a bit further. Well, when I say improvement, what do I mean? We will also go to that aspect as a part of this session. But anyway, let's say you try to improve it further. Then again, you reach at a level and you see that, okay, these are the advantages and disadvantages of a specific approach. So you again try to improve it more, right? And at some point you would reach a specific point where you would say, okay, this is the most efficient approach that I can think of. And interestingly, a few of the topics we would learn that you can somehow prove that not only me, but no one else can do better than this algorithm of a specific problem, right? So you think of a particular approach of tackling a problem, and then by using some logic, some mathematics, you can actually prove that no one can do better than this. That also that we would learn, okay? So the idea is you have to think, you have to interact, okay? So just give the basic way you think you should be tackling that problem. Next, we would incrementally build upon that to finally reach a good, efficient approach to solve the problem. Okay, so let me share my screen. Fine. Is my screen visible? Can someone respond?
Yes, yes.
Okay.
Yes, sir.
Fine. So as you can see, this is a famous code by computer scientist Donald Knuth, and fortunately, we would actually see one of his algorithms, not completely his. There is three people actually developed it together, and there are some little bit modification that Knuth made actually. So that algorithm we would see towards the later part of this course. But this is what he said. It is one of the famous quotes, very common quotes, that the best programs are written so that computing machines can perform them quickly. Okay, so this quickly, there are two minor aspects to it. I would come upon that again. When I said that when you improve a program, what do I mean by improvement? There are two aspects to it. That same thing is also applied over here. When we say machines can perform them quickly, there are two aspects to it. Okay, and so that human beings can understand them clearly. Okay, so this second point, that human beings can understand them clearly, is something that you all have to take care of. Not as a part of the technical learning, but as a part of the professional learning. So you would go into interviews, as Atul sir already said, that this is one of the most important subject in terms of your placement. Okay, so ask any one of your senior, okay, leave us, even if you ask any one of your relative, any one of a senior who is there in the sector, you would understand that for freshers, for newcomers, the most important subject that you should know as a part for giving a good interview in a good company is mostly algorithms. Even if you go for a particular specific data science oriented role, initially you would be asked some algorithm based question, then they would move to the data science part, and you can be sure about that. Okay. In fact, if you go to some good product based company, then they would even not ask you about your project or something of that sort. Most of the time, not, I will not say they would not ask. What I mean is, this algorithms questions would obviously be there. When I say algorithms, I mean data structures and algorithms. Okay. Because the idea of this subject is, again, as Atul has already mentioned, the idea of this subject is to improve your logical thinking process. So that's why I was saying that we want to interact a lot. Okay. Whenever we would cross question each a lot, we would contradict each of us a lot. Fine. So we want that kind of interaction. Fine. So now you should not only write code which runs properly, runs quickly on a system, but also you should learn how to write code so that others can understand it properly. So there are paradigms of writing code, okay, and you should follow that. But that part we would not deal in great depth as a part of this course. Basically, as a part of this course, we would focus on the technical aspects, which is the how to perform them quickly. Okay, and the second part, which is as people can understand them properly, that is mostly dealt with at a different level. And when you move to your further courses in this in our curriculum, then you would see there are subjects like software engineering and technology. So there you would learn about these paradigms. Right? Okay. A programmer is ideally an essayist who works with traditional aesthetic and literary forms as well as mathematical concepts. So mathematical concept is a bit important in order to not directly, because in most of the algorithms you would understand them by your logical or conceptual thinking, the basic logic that you have. But in order to prove something that, okay, I understand that this is a good way to solve the problem, but how to say that no one else can solve it in a better way? How to say that, okay, how to quantify the time required to solve a problem? Okay, so we would learn all those aspects. We are saying algorithms is faster. We are saying this program runs faster. So what do we mean by that when I say faster? Do we measure that in terms of seconds? Do we measure that in terms of some other unit? Or, I mean, how to quantify the fastness that we are talking about? Okay, so those things are there. So those would require some mathematical concepts, but as you all of you are here in PDSA course, I know that all of you have actually gone through all of those concepts. Fine. So yeah, so that's basically it. Why this code? I like this very much because this kind of essentially sums up what is your intent of learning programming or very particular to algorithms. So you need to make program which can be run by systems in a better way, and obviously that people can also understand. Right? Now, so I said that there are two aspects to it when we say that quickly or in a better way. If I say the system can run a program in a better way. So what are those two aspects? We would go into the details of these aspects in subsequent weeks, but just since this is an intro kind of session, I just want to discuss what are those two aspects that we are talking about. There are multiple aspects of it, but broadly there are two major things that we are talking about. Okay, so just a second. So when I say a program, right? So this is a program. Okay, this is a program. Now, can someone just tell me that what do you think? What are the factors that would that can be considered in order to tell that this program is a better program than the other?
Less line of code.
Less line of code. So basically you are telling a better storage, right? So it can be stored in a lesser space, correct?
Time management.
It takes less runtime.
Number of operations.
Proper name of variables.
Proper name of variable. So
Type safe.
Commenting each and every line to understand.
Writing comments.
okay, so those are good practices. Writing comments and all, giving proper name of variables. Those are good practices of writing a code. What I am now saying that what are the two major things that you would tell to compare two programs on the basis of their
Time and space.
Time and space.
Time management.
Great. First is time, less space. Okay, basically there are
Better readability.
better readability is obviously you can say that, but that's not something which measures the performance. I'm only talking about performance. Okay.
Sir, one question can I ask?
Yeah, please go ahead.
Sir, means anyone here said that variable name means the proper variable name, how it will enhance the performance of the program?
No. It would not enhance the performance in that manner. So that's
Yeah,
why I said
it will only improve the readability of the code. Right?
readability. Yeah, the readability, the second part which we discussed, right? In Dr. Truth's code, the second part. But now I am only considering about the first part. Yeah, someone wants to say something?
Yeah, I was asking whether a proper type safe will help in performance or not. Like writing with proper type data structure, will it help?
Type safe and data structures are two different things. So to say, you can incorporate them, but I would not say that type safe. Obviously, that's important to run your code, but performance totally depends on data structure, and that is actually from the space point of view, or how you organize the data on which your program runs. That point of view. But I don't want to correlate type safe with data structure to infer performance. Okay, getting the point. Obviously, they're related, but I'm not trying to infer that to performance.
Sir, can I ask one question?
Yeah.
Sir, in C++, what we are doing, first the programming execute to binary file, then the binary file we have to execute. But in Python, what we have to do, you just have to write the command like IPython or Python this file, then it will run that file. So is it can be a performance like in C++, first we have to convert it to binary, then it will be executed, but in Python it is direct. So can it be said like language wise the performance of C++ is better or Python is
exactly
less?
Obviously, correct. Exactly. C++ is much better than Python in terms of running time. Okay, so because as the reason that you stated, that is the proper reason. There are
it is converted to binary. That's why it is the.
Yeah, and that conversion essentially.
I think because C is using compiler and Python uses interpreter. That's why the difference in speed.
So then that interpreter is means this is the main be a factor now of this performance of the program.
So that's what I was actually trying to come to that point. Interpreter compiler, that is fine, but I don't want to discuss those things because many of you would not be familiar with these terms. What is an interpreter? What is a compiler? Was it taught in detail in Python course? What is, as a part of BSc Python course, I'm saying.
Yes, sir, it was told.
Okay, then we can go a little bit into that. See, a compiler, when it actually compiles a code into a binary file, it can make a lot of more optimizations than an interpreter can make. So interpreter can mostly apply something which we call just-in-time compilation. Okay, no need to go into details of that for those of you who are not who does not know this term. But I'm just stating it that interpreters mostly they apply a just-in-time kind of compilation, which may not do that much. Which will not be able to do that kind of optimization that a full-scale compiler can do. Okay, when I say optimization means the code that you wrote, there can be multiple optimization into that while converting that into a binary file. Okay, so those optimization make the code run faster. So that is one thing. And if you know the basic difference between interpreter and compiler, that is obviously there, which again causes some lateness in Python and most of the other interpreted languages. But So this was asked in the questions for orientation also, that why are we choosing Python to learn algorithms if C++ is a faster way to run the programs. So there are two aspects to it. First is the correctness aspect, which I would tell that it doesn't matter whether you run your program in C++ or Python from the algorithm analysis perspective. Why it doesn't matter, we would come to that in the first, in the second big content. And I can briefly state that we actually kind of develop a mechanism, not a mechanism, we develop a technique to quantify the algorithms so that we can rule out all the system dependent, language dependent, system and language dependency or resource dependency or whatever, all these kind of dependency which cause the speed of a program, which cause a reduction or increase in speed of a program, right? We would actually rule out all of them. We would devise such a technique to analyze or quantify our algorithm. What is that technique? We would come to that. Okay, so those things doesn't matter. That is the first point. So from a perspective of quantifying an algorithm, you can be sure whatever language you use, if you use the quantification of the algorithm in that manner, then it would be same in all the machines. Whether you run it on a supercomputer using C++ or whether you run it on a mainframe, IBM mainframe on Python, okay, using Python, doesn't matter. Algorithm quantification of that would remain same. Second point is why we chose Python is because apparently that's the only language that is being taught initially, because you need C++ language, most of you don't know, who are not part of this curriculum. I am sorry, who are not from CS background or any other, who have not any programming background. And another important point is here the intent of the course is not to, to understand the concept behind the algorithm. I think someone is unmuted. Can you mute yourself? So the intent of the course is mainly to discuss the working of the algorithms. Now, when you code the algorithm, you would actually gain better insights into the working of it. So it is better to write it in a language which is a bit easier and which would not add to the complexity of, writing the code. Okay. We want to only discuss the concepts. Professor Madhavan always wants to discuss. If you see his lecture, he always tries to convey the fact that we only want to focus on the concepts of the algorithm, because any language you can implement these algorithms. So Python is the best pick because it reduces the coding complexity, right? If you write the same code in C++, you have to write a lot more lines of code, although it would be efficient. So if you only want to discuss from the perspective of understanding the conceptual part of the algorithm, Python is a better language to understand the concept only, because it would actually erase out or rule out all the coding complexity that a language comes with. Okay, a bit easy language.
And also, sir, it's best for data science.
Yeah, obviously it's best for data science. I would differ a little on that. Not every time you see. Okay, so obviously for studying purpose, even for analysis purpose, Python is obviously used. But when you are actually implementing systems, right, on a data, let's say you have developed a model or anything, you have developed an application which is based on a machine learning concept, and later you are trying to implement it in some system, then there are different levels of that in that industry. So why I'm telling this is because many of you at this level have this idea that if I know Python, if I understand the basic, learning Python is not that much difficult as compared to learning other languages, which are, let's say, Java, C++. So you think that that's okay. You don't have to learn any programming language further, and you are great to go into a good company and all. So yeah, you are good to go, but the problem is this notion that Python means this is the only language used. No. Even if you go in any good company, every time they expect you to understand the concept. You should be fundamentally strong, and then you have to learn you can be working on 3-4 languages. In 1 month you work on 2 languages, in the next month you are working on separate 1 or 2 languages. So language is just something that is already expected from you, that you would learn as you go, right? It's not something that everyone knows all the languages, and it's not actually good to learn more than 2-3 languages specific to some specific. When I say 2-3 language, I mean to a specific kind of application, right? So if you have to know web development, you have to know some coding. So depending upon that, there are 4-5 sectors, and you should know at least 2-3 languages to deal with each of those sectors. But you don't have to know all the 3-4 languages which actually is pertinent to a specific task. You have to work with that when you go into the, in your job. But don't keep this notion, you know Python means that's it. Every time you have to learn languages on the go. Okay, so that is one thing. And other part is, I was saying that when you implement a specific algorithm, maybe that is machine learning based something, but when you implement it on systems, you would see that there is some system performance associated with it, right? As one of you said, C++ is a good option to do that. So we use tools. I'm not saying we don't use tools and we write the whole thing in C++ or maybe some other language. We use tools to port some part of the Python into some other language which is more system oriented, which is closer to the system. When I say closer to the system, that means which can run faster on the system. That's it. You can think of it like that. Okay, nothing more is required at this level. But okay, so you will do some porting, but many of time you would see that some parts cannot be ported if it is a complex application. So you have to write at the end of the day, you have to port it by manually writing code. So what I don't want to disagree with you that Python is the most essential language for data science. Obviously, it is the most essential language for data science. But don't keep the notion in mind, if I know Python, I don't have to learn anything else to work in a data science. That's the motive I want to convey. Okay. Great. So yeah, so I was talking about this thing, right? That there are two aspects of quantifying a program, which is less space and less time. Now we would mainly focus in this course on the less time aspect, but obviously less space is another important factor. And we would, while we discuss each algorithm, we would also go and discuss a little bit about the space concept, how it is done in a little space. But mostly we would focus on the timing aspect, because that again has a relevance with the real life scenario. Because if you, basically the thing is you have a lot of space now. It's cheaper to have more space as compared to speed. That's the idea. Okay, now technically there is something called the memory wall problem, not required for those of you who are having some CS background or programming background. You can look it up and check it out. Just for enthusiasm, I'm saying you can check out of interest what is the memory wall problem. And that actually boils down to this fact that timing is something which is of more concern than space. So yeah. Okay, till now, any questions? You can ask any questions, any type of doubt which you have. Yeah.
The performance of the program and also measured in terms of the security concerns.
Sorry, I cannot hear you properly.
Programs can. Performance of the program can be measured in terms of the security concerns of the program.
Security concern obviously is another important factor.
Because these security concerns are more important than this less time and less space.
Okay, so let me just, so if you have seen the first week all the lectures, right? So just check all the lectures. If you have seen, you should have, understanding, get that part. But if you have not seen, no problem. It's only Wednesday. So go through that. There would be one example which sir is giving. So basically to check your, so I'm just repeating that example only, but there can be thousands of examples like that. I'm just telling that if you are, let's say there is something you are trying to match the Aadhaar number. So you write your Aadhaar number, right? And that Aadhaar number is being matched with all the Aadhaar number which is there for all Indian residents. So that if we have something of the order 10 to the power of, let's say, hypothetically, or I don't know about the population, but let's say if it is around 10 to the power of 8, right? And if you do a simple check that whether this given Aadhaar number is equal to the first Aadhaar number, second Aadhaar number, third Aadhaar number, up to the 10 to the power 8 Aadhaar number. Okay, so that might take you a huge amount of time. And when I say huge amount of time, that can be in hours, minutes, and if you go for 10 to the power, let's say 12, 13 or 10 to the power 14 range of entries, it can actually go up to the age of the universe. That is, you have to just calculate that. You can get that. A single program can run up to the age of the universe and still not stop. As simple as checking other number. If the number of input is, if the size of the input is huge. So security concern obviously is there, but if your program is not performing only, then where security is coming? It should work properly, then comes the security part, right?
Okay.
So security part we would discuss in more detail in the application development process, right? So you have an application, you don't, I mean, you know the working, how that application is working, you have developed it. Now you want to bring it in front of the whole world. How you would bring it in front of the whole world? You would most probably make a web app, or you would make an Android app, and then others would interact with that, right? Something like that. So when you do that, then comes the concern of security. And obviously there are aspects to how you have a check for that, checks and balances for that. Those would be covered in the application development process. Okay. Here we would mainly consider the inputs. Yeah, input sizes more, how we can improve. Yeah, any other questions?
Sir, hello.
Sir, I have a question.
Okay,
Sir, you said like
what we can do is, so all of you who have questions, raise your hands. Okay, I would actually check whoever has raised hand, and one by one I would ask. So yeah, Abhiraj, please go ahead. All of you may raise your hand. Keep your hands raised, and once your doubt is clarified, you please lower your hand.
Sir, as you said, like C++ is more efficient than Python, but I think it depends more or less on the programmer that how he is implementing the code. Because if we use in C++, if we use a for loop, or if we use Python, but we use some data structure, so I think Python one will be more efficient.
Correct. But what we are trying to say when we compare between two languages, so whenever you compare two things, what do you do? I mean, in terms of, I mean, you all have learned mathematics courses and statistics courses. When you compare two things, you try to make the other aspects of that same concept as invariant, right? So you try to fix the other thing so that you can only judge two elements on the basis of their, I mean, on the particularly on the basis of which you want to actually compare them, and you want to make other things as constant or invariants. So when I say I compare Python and C++, I mean that the code and the algorithm that has been written and that has been tested on that will be tested on Python and C++, they are exactly same in terms of their I mean, if I want to say in terms of their complexity, that is, we have not yet come to the term of complexity. What do you mean by that? What I mean is they are exactly same in terms of their, I mean, particularly to the logic of the code. Okay, so not language or not system, not computer hardware speed. Keep all those things aside. The logic, how the thing is working. If you keep that thing same for Python and C++, and then check the same code in Python and C++, then you actually measure the performance, and you will see that C++ binary file is running much faster. So you keep the other aspects of the code as constant when you compare between two languages. That is, I assume that everything is same. The code that is written in C++ and Python is same. Okay. When I say same in terms of their logical speed, when I say logical speed, that is basically, I mean, how the logic is performing, how the core of that algorithm is performing. So that is same. Okay. Then due to the language and system dependencies, the speed is same. Yeah, Devashish, go ahead.
Hello, sir. Sir, actually, I just want to know, in recursion, we are using stack memory. If let's say there is a program, let's say, and I want to optimize that program. So should I use recursion or should I use other logic, optimized logic? Means I want to ask that. Should we means using recursion? Can you optimize a algorithm or not?
Good question. So I would actually come to this. I was planning to come to this recursion topic because let me just add one more reference over here. So those of you who have seen the first week all the lectures, and those who have yet not seen, I'm still mentioning. So in one lecture, sir is stating while using the recursion lecture that there would be, when you run the recursion for a huge input size, right? So you are calling the recursive function a lot of times. When you do that, at some point, you would get an error. Okay, so what is that error? So let's say I run a loop for maybe 1 crore times. I would not get any error. Okay. So I run a loop, something like, let's say I run a for loop for I in range. Okay, let's say a lot of times. Okay, but if I try to simply do a recursion call of the same thing by calling the function for 1 crore times or whatever, you may get after a certain value, you obviously would get it, but depending upon what is the size of the okay. So let me just ask this question: in the Python course or in any other course, have you all been introduced with the concept of what is the system stack when you do recursion? Do you know what is the function call stack or system stack?
So basically, the stack memory
The
is used,
stack
I guess.
is like, we know, so like,
Yeah,
Like
I'm not-
a function
First
waiting, a
is
function is
stack
waiting for another
memory.
function. So this is using a stack concept. Like first a function will be there, then after that when it call that same function, after that another function will be there. Like it will be stacking. So
Correct.
that when it will use a stack memory.
Or stack
Okay.
function is like a drawers, a lot of drawers having spaces in which we can keep stuffs.
Correct.
like
Correct.
first
I
in,
think
Sir,
first in, last out.
First in, first out.
First in, last out.
So my question is a little bit different. Okay, I got the idea that most of you know it, but what I am asking is it being addressed? What is a system stack, not stack data structure? What is a system stack in any of the courses?
No,
I mean,
I guess it
No,
is not
sir.
addressed
So is it
properly.
related to the activation record?
it is activation record only, but I just want to discuss it briefly then, because many of you, since it is not discussed as a part of the curriculum, I want to discuss. Then we would come to the question of how we can use recursion, whether it optimizes something, whether it makes it worse. What's the thing we would come to. So what is the system stack? All of you know about stack, that I understand. You all have done in Python, and in CT a little bit also you all have known. So stack, as you all of you said, that the element which comes last into the stack goes out of the stack first, which is follows the LIFO order or last in first. Those things are fine. Now, what is a system stack? A system stack is, so let's say if I call a function, I'm not using any specific language syntax. It's just a kind of pseudocode which is used in CP, that kind of thing. So let's say I have let's say I define function on one. Okay, and I have some lines of code over here, and then as a part of this function, I here again, if some condition is satisfied, okay, then I again call the function. So this is basically recursion, correct? Now the thing is, whenever you are calling one function from another function, so let's say let's keep it as case 1, this is recursion, or case 2, this is our recursive case, and this is a simple non-recursive case. So let's say there is function 1, which is again calling function. Let's say we have function 1, and we have another function here, which is function 2. So let's say the body of function 1 is over here, and function 2 over here calls function 1. And assume that function 2 is the first function that is being called the first time when the program starts. Function 2 is kind of the main function. You can define the main function, right? It's kind of the main function. So the thing is, what will happen?
Function 1 is the main function.
No, 2 is the main function, and assume that 2 is being called when the program starts executing. Okay, if that is the scenario, assume that. So now I am saying if function, so let me just mark it. Let me just rename it then there would be. Assume this is the main function. Okay, so this is your main function. I'm just writing a pseudocode, and main function is calling your function 1. You know that main function is the first function which is being called. Okay, so what would happen internally is, for every function call, sorry, not for every function call, what I mean is for function calls, in order to maintain these functions, right? there is something called a system stack. Okay, so let's say this is a system stack. So this is just like a normal stack implemented inside your primary memory or the random access memory. So you don't have to go if you don't know what is a random access memory, no problem. So it's basically the RAM or the physical memory. So it's the memory which is where all of your program would be residing. So when you are actually running a program, it must stay at a space, right? And then you want to run it on the processor. So RAM is the space where your program stays primarily, not on. So yeah. So system stack is a data structure implemented inside your RAM, and it would have records corresponding to each of the function calls. So the bottommost record would be main, because main is the first function which is being called, and then there would be again a record which is function 1. Okay, and assume that after function 1 I am calling function 2 over here. Assume that there is some function called function 2 which I have defined, and also let us add a little more complexity to this part. Assume that inside function 1 I am calling function 3. Okay, so mains part is up to this. So this is my main. Okay, this is my function 1. So inside function 1 I am calling function 3. Now what would be the structure of this step? Main, then
Main,
after
function 1, function 3.
Correct. So when I come to the main body, I see function 1 as the first call. So I put function 1. Then what would happen? Will the next entry be function 2 or function 3? Function 3. Why function 3? Because when I am experiencing this line of code, which is function 1, I would execute that, correct? So when I execute this, my control will shift to this point inside function 1. So I would go inside function 1, then I would see that inside function 1 I am calling function 3, right? So I would add function 3 as the next function in the sequence. Okay, and then let's say function 3 is somewhere else. I go to function 3's body. So from here I would go to some function 3. Okay, I would complete the execution of function 3 and then return back to this line just after the end of function 3, which is inside function 1, right? So when I return back from function 3 into the body of function 1, because assume that function 3 did not call any other function. It was just, it did not make any function call. It just completed, it had a loop and it executed. So I returned from function 3 into the to the next line of function 1, right? Because function 3's line is, let's say, line number 2, and I have returned to line number 3 inside function. Now line 3 is not there. Function 1 is ending after calling function. So that means what? Function 1's only work was there. Only work was to call function 3. If there would have been some lines of code in the third line, in the fourth line of function 1, then I would go on sequentially executing, right? But I don't have any lines of code. So essentially, function 1's job is also over. And now this line which I do, so I will come back using this line to the next line of main function. Because function 1's job is over. So what did I do? Parallel in the stack, what would happen in the system stack? When you came back from function 3 into function 1, when you came back from function 3 into function 1, then as soon as you go out of function 3, right, you return from function 3, your function 3 will be eliminated from the stack. So it would be removed. Okay. Now you came to function 1, and again function 1's job is also over. So again function 1 is also removed. Parallelly, this would happen. Okay. And now at the end you are coming to function 2 now. So you are calling function 2. So function 2 would be added over here as a separate thing. And let's say you complete the execution of function 2, which did not call any other function, and then you come back from executing function 2 to the next line of main function, and main has no other task to do. So function 2 would be removed because you have executed function 2, and you come back to main and complete the main itself. So you also remove main, that is you pop main. So once your system stack becomes empty, that is the termination of your program. Okay, so your program terminates. Now if you ask that in some programming languages and even in Python, main function is not necessary to define. So in that case, how the program terminates? So you are not defining main function. or any other specific function, but for every program that you run in every language that you use, there is an entry to that program. That entry may not be a function, it may be something else also, but that is not relevant in this course. But there should be some entry point in the program. Okay, and it may not be a function all the time. It may be something else. So what is that something else is not relevant. But the entry point should be there. That data corresponding to the entry point should be there as the last entry in the stack. And when that entry is popped out, that means your program is terminated. That is, I mean, it's completed successfully. And okay, so when I say that stack with main function, function 1, function 2, right? Let's say fun2, fun1, main. So is it just kind of a string storing main, fun1, fun2? No. When I say fun1, fun2 and main records corresponding to this function, there are a lot of records inside this spaces. I mean, for corresponding to fun2, there are a lot of records. That's not relevant as a part of this course, but there are a lot of records which help the compiler or interpreter, basically the control flow of the program, to return back to the proper place where this function left. So I went from function 1 to function 3 over here, but somehow then I returned back to the proper line of code, just to the next line of code of function 1. So we have to remember, right, that function 3 call was at line number 2. I would go to function 3 and I must return to line number 3 of function 1 after I execute function 3. So these kind of information, and there are a lot of informations. So those are stored as a part of this system stack. Okay, even the variables, not all variables, but many variables. When I say not all, again, those aspects are not relevant, but while discussing algorithm, if that comes up, we would discuss. Some specific variables are stored as a inside the stack of these functions, and some other variables are not stored. Okay, so what I mean is these stack frames, which we call system stack or function stack or call stack. There are multiple names. You can call them call stack because you are basically storing the result of, storing the sequence of function calls. So call stack, you can call them system stack, you can call them, I mean, there are a lot of names to them, but they basically store information relevant to a specific function call, so that the chain of function calls can be maintained somewhere. So this is system stack. Now let's come to the recursion. So if this is system stack, obviously the stack has some definite amount of space, right? Because your RAM memory is definite, it's not infinite. And for a particular program, some specific part of the memory is actually allocated. You cannot go out of that, right? Because you run a lot of, you are playing a music, you are doing something else, watching a movie, maybe attending a meeting in parallel. So all these tasks are running in parallel in your RAM. So obviously, your operating system, your computer must actually, basically your computer must actually allocate some specific task to each of these softwares which are running, right? I cannot allow you to have more space than this because my space is limited. So if for every program I have a system stack, okay, and then there should be a limitation on the size of this stack, right? There should be a limitation on the size of this stack. Size is limited. So if the size is limited, you can obviously understand the number of frames are basic. So these are called records or frames or activation records. As someone was saying, are these activation records? So these records are basically also called activation records. Why it is called activation? All those things not required. Basically, you can think because you are activating a function call, so it's called activation. So these are activation records, and many a times it was also, these are also called stack frames, or also called your function call frames. Any of the names. So basically, the idea is this: since the space is limited on stack, the number of function call frames that you can put into it must also be limited. Correct? You cannot call arbitrary number of functions, an infinite number of functions. Now come to the recursion. So what is happening in recursion? Here I was calling main was calling function 1, maybe function 1 was calling function 3, and I'm returning. But let's say I have a recursive call which goes around for, let's say, 1000, 2000, or more than that, let's say 1 crore number of times. What would happen? I would have function once, how the recursive stack, how the stack would look in that. Okay, so obviously at the bottom, assume that there is main. Okay, so this is for my case 2 recursion, and assume I am making a recursive for which is going so many times. So my bottom part is main, and then what would happen? The next record would be function 1, the first call to function 1, which is done from inside the main method. So this is inside main, called inside main. Okay, function 1. Then again, since this recursion, again I would put again another entry for function 1, because the first function 1 invocation would again invoke function 1 for the second time. Again, corresponding to this invocation, when I come to this part, I mean corresponding to this second invocation, again I would come here and I would call a third invocation. Accordingly, this would go and that would go for this many times, assume. So I would have so many number of I should have so many number of activation records or your function call frames in the stack in order to solve this problem. Because you know recursion goes from it goes to the top to bottom and then it returns from the bottom to top, right? So it would go to the last level of the recursive call and then come back one by one. So you should have a depth which is corresponding to these many number into the size of each record. Size of each record. So that much amount of space should be equal to your stack. That much amount of space should be equal to your stack. So this may not satisfy all the times. So you may have a limited amount of space and the program would say as soon as you cross this space, so this is your bottleneck, you cannot go beyond this line. And as you cross this line by adding one more entry corresponding to the next recursive call over here, it would say that, okay, you have crossed your allocated limit and I would not allow you to store more stack frames. That is, you are not allowed to make a next level of recursive call. And this situation, when you are not allowed to make a next level of recursive call, that we call stack overflow. Now I think you all should be clear why do we should be clear that why do we call it an overflow and why do we call it stack. So now to coming back to answer that question, whether recursion can be used to optimize a code or not. Recursion can be used to increase the readability or easy to understandingness of your code. But the idea is every recursive call, every program which is written in a manner of recursion can be converted into an equivalent program which is written using iteration, that is loops. And every program which is written using loops can be vice versa, it can be converted into a program which can be solved using recursion. So these are two, one-to-one mapping, that is basically every recursive function can be equivalently converted into a loop program, and every looping program can be converted into a recursive kind of manner. So this is a theoretical proof in computer science algorithms, but you can do that. Now, if you can do that, this evidently means there is no, from point of system perspective, recursion may be bad in some sense, but again, it increases the readability. But in terms of complexity, time complexity, I would not say recursion can only provide you an advantage because I can always have an iterative program which can provide you the same complexity. Yeah, Devashish, you want to ask something?
Yes, sir. You have said right now, like every for loop means every iterable loop, it can be converted into recursion. So, so in like in DSO we are studying. So first, let's say we'll optimize a code. Okay, a code is there, and we'll optimize it at a certain level. After that, we can implement a recursion in that optimized code. So it will be a highly optimized code, Nathan.
So that's what I was saying. You can apply recursion, correct, in order to increase the readability.
My doubt is, so every problem can be converted to recursion. Like, so it is possible. Like every problem, a iterable loop is there. It can be converted to recursion.
Correct. That's a theoretical proof in computer science. you can, if you're interested, you can check that book online. It's mainly a mathematical way.
I am
prove it,
saying
but-
about practicality. I means it may be possible.
Yeah, obviously, if something is proved in theory, obviously it incorporates all the things in practical. But if something is proved using practical, it may not satisfy all the theoretical lemmas. So obviously, it is doable to convert all programs which are running in an iterative manner into recursion, and vice versa. No problem with that. But what I'm saying is, in terms of gaining efficiency, in terms of timing, you may not get that, because when I'm saying that this is equivalent to this, iteration is equivalent to recursion, I am, by making that statement, I am actually contradicting the fact that you gain an advantage in terms of timing when you convert a program from recursion to loop or loop from a recursion. So they are equivalent. There should be some way that you can manage to write the code in so that their timing should be same. The concept is in terms of the system. So this is the other aspect. We discussed two aspects, right? Space, system, and timing. So when you do recursion, you may get into this overflow kind of situation where if you use loops, you would not get into that kind of situation. So in fact, using recursion may cause you harm in terms of system perspective. But again, the advantage of recursion, only advantage over loops is that it makes your code much more readable. It makes your code much more smaller. Making a iterative program, it may be, let's say, 15-20 lines. You can manage to use some intelligent recursive logic and do the same program in 3-4 lines. Have a base condition, have a that is the termination condition, the recursion would stop, and then apply the recursive call. So same thing can be done in 2 lines. So let's say the Fibonacci number, all of you have done. So in order to do the Fibonacci number, you have to make a for loop. In that, you have to have ABC variable and then add the variables accordingly. So you need 3-4 lines and a loop. If you want to do it in a recursive manner, you just have a base condition and then you simply call Fibonacci of n-1 plus Fibonacci of n-2, and that's it. 2 lines of code. You need base condition, if condition, 1 line, and then the recursive call. So it's not something that would fetch you advantage in terms of timing. In fact, recursion can actually worsen the system perspective, the system performance of the algorithm, and you may run into overflow. But it increases the readability, it makes the code much easier to understand. That's the, that would be the bottom line. Yeah, someone was saying something, and then I would come to Saurabh. Just a second. Was someone unmuting, trying to tell something? Go ahead.
Yes, sir. Sir, you are saying says theoretical proof. Okay, we can every code write in recursive form. Yes, sir. Is there a proof in computer, sir?
Yeah, you can check that. It's not. So see, everything has a corollary, right? So go into theoretical aspects of it. So there is some other statement, and from that you can draw the conclusion. There can be or let's say you can frame it in form of corollary that you can do.
Okay. Thank you,
sir. Okay. Thanks. So yeah, Saurabh, you please go ahead.
Sir, I have gone through the week 1 content. I have understand the logic, but I am not able to code the PPAs and graded assignment very well. I am not from programming background. I just completed the Python course, but I am not very good in programming. I just managed to pass by 52% of the scores. How did I get to complete this course writing a code efficient when I am at this time I'm not able to write a proper code for that? Then how would I manage to write an efficient code for that?
Okay, so writing the efficient code, that is you don't have to worry a lot if you are sincere throughout the course, because that's what we would discuss in detail as part of this course. But writing code in Python is something that is expected from all of you. Basic code, you don't have to, basic code you should be able to do. So let me just give you the example. So this week, this recap week, right? Python recap week, you should be able to do all those things in the first week. May not be in 1 hour, 2 hours, but since all of you have done Python, this is what is expected from all of you, that you know basics of Python. Okay, so how to write simple code, that you should do. But what I want to address, and that is one very important point, which is a very important point regarding this course, that honestly, this is kind of a bit dense course, and understanding the theory part and the idea behind the algorithm, and also learning how to code it up, it would be a bit more extensive for the first timers. So the answer to this question is you have to practice writing code a lot. If you want to excel in writing code, see, OP is not compulsory in PDS, right? Compulsory means it's not in the grading. Just a second.
So I guess it's there.
Yes, it is there, I guess. OPP is some mark it is holding.
It's
Yeah,
of the OPP.
Its contribution is there, but what I see, it's not compulsory that you. So some courses, in order to qualify for the next level, you have to actually pass the OPP, and that's not something
in
that
Python it is 50%, I guess. That is not present, I guess, in PDS.
Yeah. So in fact, in some courses, you would also have to pass the OPP for sure. I mean, you have to pass it. If you don't, and even if your percentage is good, you would not be allowed to proceed further in the curriculum. But in PDSA, that is not the case. So let me clear that. But I would request all of you to do the coding properly, because otherwise you would not be able to solve the graded programming assignments. So we would discuss as a part of the live sessions all the coding, all the algorithms, how all the codes of these algorithms. But you should be able to, if you understand the coding of the algorithm line by line conceptually, okay, then you would be able to solve the graded programming assignments easily. Okay, but in order to do that, you should understand the code of each of the algorithms that we would discuss as a part of the sessions. Yeah, so two other participants, yeah, go ahead, Devasis.
Okay, so thank you.
Sorry?
Yes, sir. Sir, actually, I have been gone through all the lectures. Actually,
Okay.
there are in the lectures there is a various version of prime. Each prime means a number is prime or not. There are various version, and at last, the last version is like something like while. We are using while instead of for, and we are using the square root of n up to square root of n. I got that what is the logic for the square root of n, but I don't understand why it means he is using for loop instead, means why he is at last he is using while loop instead of for loop. We can also do that in for loop also, I guess.
You can do that, no problem.
Yeah,
you have to modify the code accordingly.
Yes, I have to modify. I agree to that, but that means in lectures at last he said that like for instead of using for loop, we should use while loop. That is a doubt I am assuming.
See, the thing is, there you are going one by one and checking. You are not giving a range. I mean, you are using a range, that is fine. So the idea is whatever. I mean, using a for and while loop, which has been addressed over there, that is pertinent to Python only. How in Python you are trying to do it. If you can modify the logic and use a while loop, use a for loop accordingly, then there is no problem with it. The main part is you are running the iterations up to root n number of times. That is the main part.
Yeah. Actually, what he has done, he is using for loop initially, and he is using break. Means whenever whenever that number is divisible by
I understand
any number.
that is correct. That is basically to, to convey the idea of, so Python has a specific syntax for loop, while loop, right? So that's just a way to convey the idea that you can do using for loop, you can do using while loop, but your number of iterations using the for loop, you are doing it n times, n-1 times, and here you are using it root n times. But if you can modify your while loop by for loop by just running up to root n times, there is no problem. No,
yes, means
okay.
he has said that break is not preferably used. So we means to avoid the use of break. That's why he is using while loop, I guess.
That is a little bit. So those understand those things. Just listen to those things and keep those things in mind. But there is a much more. So in order to understand why break is a bad thing to do.
Yes, I want to add something, sir.
Yeah, just a second, I will come to you. So why break is bad? That is itself a very, not very, but it requires some concept of other subjects of computer science in order to understand why using break is not motivated. Okay, so basically, if break it up in very simple terms. I may be making some errors in order to simplify this, but the idea is like this. So if you use break, you are breaking the normal flow of control, right? The program proceeds sequentially, or maybe if it is a if condition, it will skip one or two lines, or maybe the block of if and then come to the next if or else statement. But what is break doing? It's moving out of the loop. If it's a function, so whatever the loop body is, it's moving out of the loop by ignoring all the next iterations. So as you all said that what are byte codes, right? Some in the start of the discussion we had. So when you are actually converting your programming language code into the byte code or in the assembly language code, one step ahead, one step before the byte code. So what happens is all this statement that you write as part of the Python language, they would be converted into assembly language. And in assembly language, there are very specific instructions which are called the jump instructions or branching instructions. So break cause a huge branch, or it cause the program to jump a lot and very arbitrarily. And in order to make that jump, it actually loses a lot of performance. Okay, so that's the idea. Just it's not required. That's why I kind of note that. But
okay, got it. I got it.
Okay, so those things are there.
I just want to one thing extra. The professor had discussed about the HCF or the GCD,
Okay.
and that optimum solution also he had given. So at last he had gone to that Eclipse algorithm, which is like using a
reminder.
Reminder, which is using a recursion also. Means using recursion he is doing. So here in this code, it is first optimized to like a Eclipse algorithm. Then it is used recursion to again enhance the code, I guess. So means can you?
Correct.
Yeah.
So say.
Yeah, means I just want to know, before Euclid algorithm, he has using the recursion, but he is using GC, means in recursion he is passing the two values. One is the minimum value and another is the difference of that values, a minus b. But in Euclid he is passing that remainder value, the minimum and the remainder value. So can you means demonstrate like using 2 and means he has done 2 and 4 9, so that it will means in this use case the above one will take more time, but the GCD by Euclid algorithm will take less time. Can you just explain me like how these things?
You can just so you want to understand the maths part of it or the programming part?
No, not the math part. I just want to know how it is enhancing from B a minus b to a modulo b. That is the thing I just want to.
Okay, just do this. Okay, as an exercise, since you already understood the math part. Take two numbers, okay, and sir has also discussed that only. So when you are actually subtracting, right, if you are doing a minus b and then doing that, how many times you have to do minus in order to reach your solution? And if you do using that remainder finding process of Euclid's algorithm, then how many times you have to do that step? In mathematics, in copy, just write and check how many steps for same two numbers you have to do using the subtraction method and using the remainder method.
So any number I can take, right? Means
any number. I mean, so for bigger numbers, you would get a better idea of how many is the difference.
Like I am just thinking about an idea. Means in these two code, can we keep a variable called count, and I will initiate it to 0, and in both the cases I can increase that count value so that it will give me the operation number of means operation it had taken. And after that I can get that which is taking maximum, means which is taking more operations, I can get that value, right?
But when you define a count variable and you are calling a recursion call, you have to define it in a specific way, right? Because in the recursion,
and that is the thing I am actually asking, like means I don't know like how to do that. If I am thinking in that way. Let's say I have these two problems. I just want to know what are the number of operation. Like in case of a minus b, what are the number of times the GCD value. GCD
just make a parameter, no? I got it. If you want to define something like that in Python, Static concept, you don't need to have a static variable and all those things. What you can do is simply make a variable which you make count. Okay, so let's say your function is this. Okay, GCD here the first parameter, second parameter, have a third parameter called count. And every time you are inside GCD, increase count.
Or increase this count, yeah. Then at last, after all the recursion, it will tell me
so
what
you
is
pass
the
A, B
number of
percent A,
times.
whatever you want to pass, A, B percent A, and then you pass the count. That's it. And at the end of the day, let's say the base case, whenever here you would have the base case, right? For GCD, when it terminates, you would return the number, correct? So at that time, return the GCD value, whichever is your.
Yes, it will return then 1, na? In case of count. Count is equal to 1, I guess.
You can print the count, na? You can do a lot of things. So let's say right in base case, then just print the count and return the number. I mean, return your GCD. That is simple Python. Just you can take care of it. So if you do that, if you check the count, you would see that when you apply remainder, it takes a lot more number of steps. If you take big numbers, you would see that it takes a enormously more number of steps than the.
Yes, I got it. It will take many numbers, obviously, because one is getting dividing and getting the remainder, and another is just subtracting. Means logically, it will be higher.
And what are the implications? Let me just also point out two things. What are the implications of that? First point is it would take more time. That is okay. What is the second point that I just discussed? It would take a lot more of stack frames. Correct?
Yes, it will definitely lead a stack memory. It will access all the stack.
So that's why if you see in the one of the lectures just after that, where sir is discussing the code, where you apply GCD on a specific set of number, you get a stack overflow error after a certain point. So that is also discussed. You can check the. Okay. So next is Devashish want to say, and then I would come to Pune.
Hello, sir. Shekhar here. Sir, I doubt that in recursion, if we use a break statement, so how the controlling is affected in the activation record.
Sorry, who is speaking? Is it Devashish?
No, sir. Shekhar.
Okay. So go ahead. What are you saying?
So I'm saying in recursion, if you use a break statement, so how the control link is affected in that activation record.
So break statement, if you are making it inside a loop, then activation record is not affected because break is used for moving out of the loop, right? It's not used for moving out of the function scope. Activation record would only be affected. Activation records are basically functions for functions. So when I'm moving out of function, when I'm returning back from function or moving into a function, then the activation record would be popped or pushed respectively. But for moving out of loop or if statement or break statement, continue statement, these do not affect the activation record because they are not functions. And that is the point. That is the point I was saying that recursion, some program in recursion can give you overflow error, but same program done using the iteration, that is for loop or while loop, basically loop, would not give you error. If activation record was also associated, would have also been associated with looping, then for loop also you would get a overflow error, but that you do not get. So Devashish, go ahead.
No, sir, I have lowered my hand, I guess.
Oh, acha. Okay, any more doubts?
Sir, I have a doubt in my PPA.
Okay, practice programming assignment.
Yes.
Okay, so
have a look on that.
But let me tell you one thing. So this is a Python recap week, right? So that's what I was saying. It's expected from you, but you can tell.
I had written the code, but the thing is that I think everything is right. But I'm not asking for you for the code, but I think it has the slight error. All the public test case is passed, and some of the private test case has also passed, but some I was not able to pass some, and it is also not an efficient code. So just give me this, brief me on that.
Which problem? Which
PPA
twin primes? Sorry, I cannot hear you. Is it the twin primes problem?
Yes, sir. Yes, sir.
Okay.
Can I tell means I have done that already.
I would actually discourage that now. I mean, do not I mean, it's Wednesday only. So try to do it. You said that you are not able to pass some specific test cases, right?
Yes, yes. Some private test cases.
Okay. So it's asking you that returns all unique twin primes between the given two limits.
Yes, sir.
Okay. So you are not able to pass to specific test case. So only thing is you have to check for prime property and also check that whether the next to next number is following the same property, which is a prime number. So how you have done it?
Sir, actually I have written two functions. One is like checking for a specific number that it is a prime or not. Like, and second function is twin prime.
Have you checked whether the function which is checking for prime is it incorporating the fact that one is neither a prime nor a composite number?
Yes, sir.
Okay.
And second function is twin prime.
That is fine. I'm just telling. Two, three things generally people miss. That is, one is neither a prime nor a composite number. So you have to eliminate that out while computing.
Yes, sir.
Okay. So second point.
Can I say something?
Yeah, go ahead if you want, but do not tell in detail.
No, I am not telling anything. I am just asking. I mean, in internet, if I search one is a prime or not, it is so that it is a prime. But I know in mathematics, one I guess sir had told that one is not a prime. Means for this course, like I guess.
No, one is not a prime number. It's
yeah,
not
that's why we are.
Yes, I know that one is not a prime number. But actually that is the thing, means I am saying that that is the catch actually in this problem. If we are not checking one is prime or not, then it may fail the private test case.
No, actually I'm checking from 2. So
that is the problem, that one is not checking, means you have just add to a condition like.
I put that condition. I had put that condition.
So okay, if there is so if you are saying that by putting one as prime the code is working, then
no, sir. He means that I don't know what he means.
No.
I mean that if a number is there and that is 1, then you have to return that it is a false. It is not a prime.
Yeah, correct. So that was also I was also saying. Yeah, so that's the only thing, right? There is nothing more to it. Just check whether there are some other errors that you are doing. Only that fact is there. Other than that, if it's a prime, just you have to check whether the second number we are comparing that is +2 or not. That's it. Run a loop, increment accordingly. Check whether the i+2 number and I number both satisfy prime or not. In any case, if both of them are true, have an AND condition and then just return true. And checking the prime, take care of the fact that it should be, that one pair. One is neither prime nor composite. It should be doable, no problem.
If you are using for loop or while loop.
Whatever you use, that doesn't matter.
I think the loops doesn't matter in the efficiency. Not a lot matter in efficiency.
So in the first week, do not think about efficiency. We have not come to any point. This is just an introduction of how the things would turn up. What are we going to learn, right? So as of now, just you have to code the things in Python. That's it. Kind of a basic recap. Once we come to the efficiency, at first we have to understand how we quantify efficiency. So that's what I was saying, that you have a tool that you use to quantify the algorithms, right? Which would rule out all the system dependency, programming language dependency, all those things. Once you do that, that is your first step towards the efficiency. Once you do that, then you have the tool to check the efficiency of a program. And then we go to the algorithms and use that tool to say, okay, so this program is more efficient, this program is less efficient. Okay, one more important fact I forgot to mention. So when I say algorithm or approach to solve a problem, so there are two aspects of improving the timing performance, not the system performance or space or all those things. Particularly the timing performance in two ways. Either you change your approach. I mean, you totally think of a different way to tackle the problem. Or in some cases you can, or maybe in most of the cases, what you can rather do is you see which kind of operations I am doing in the problem or in the approach that I'm taking to solve the problem. In that approach, which kind of operations I am doing more number of times. When I say which kind of, just keep it at that only. We would go into the detail and then we all will understand. So kind of operations mean, let's say insertion, deletion, traversing, these are basically the operations. So now depending upon how you are performing and how many times you are performing these operations in order to solve a problem, right? We would actually try to use the data. So when you have, let's say, I mean, you are applying the algorithm on some input, right? So there is a way to represent that input, which is your data. The input is a data, right? So you use the input or the data and represent it in some specific form, so that when you apply the algorithm, when you apply the algorithm on that specific representation of the input or data, the kind of operation that you apply more number of times as a part of your approach or algorithm, those operations can happen quickly on that particular representation of data. If you apply the same approach or algorithm on a normal representation of the data, just take the input and apply the algorithm, maybe it works a little slower. But when you represent that data in a different way, right? What are these different ways? Those things would come in the subsequent weeks and lectures. So when you represent this data in a specific way with some properties, then what you can get is the operations that you do as a part of your algorithm on this data, right? You get a better running time. You get a better, I mean, you can do those operations in less number of times. So when I say the representation of data, that is essentially your data structure. So you have the data, you can represent that data in different formats. Each of these formats are separate data structures. The property of these data structures actually help you to operate some specific kind of operations faster. So if you, let's say insertion is one operation, you can perform the insert operation in one data structure very fast. In other data structure, it may be a bit slower. But if you want to take out the data from the data structure, maybe the one which was giving insertion at a faster rate is now working bad, and the one which was giving insertion at a slower rate, right? Now that can give your data output. The output can be faster in that data structure. So now you have to analyze as a part of my approach to solve the problem, which operation I am doing more. If I am doing insertion more, then it's better to use the data structure to represent your input data in that form when I'm getting a better running time for input, where I'm getting a lesser running time for input, and accordingly we do. So there are two aspects of improving the timing performance of an algorithm. The first is you change your way of approach, that is you change your algorithm. The second is you keep your algorithm same, but you change the way the data is represented, and that's why you make, you take lesser time to. Just a second. So you take lesser time to, to do the operations. So there are two facts. So the first is algorithms, the second is data structure. Now you can use the mix and match of this. You can change the algorithm, you can keep the data structure same. You can keep the algorithm same, change the data structure. You can change both of them and see better results. So that's where the point of incremental improvement comes. That first we reach this level, then we say, okay, we can do better. So we go for a better approach like that. Okay, so we would expect all of you to actually, while we go into the algorithms, to tell actually, okay, what if I use this data structure? I can get a better solution? Or what if I use this approach on the same data structure? Then I can get a better solution. So yeah, all kind of permutation and combinations. But for that, we have to learn this data structure. Data structures are the tools to implement your algorithm in a faster way. Okay, so we would do all those things as a part of this course. Did you understand the gist what I wanted to say? What is the difference between algorithm and what is the data structure? The basic difference between these and how you gain performance by mixing matching these two.
Yes, sir.
Okay. Yeah, Devashish, you want to say something? You have raised your hand.
Yes, sir. Actually, means what I understand from your saying, like you are saying that if a list is there, and in list we can insert and we can insert data and we can update data in any index. But if we means if we modify that list into a stack type structure, then we can only means take the last item and we can means insert in, it will be in last in first out in that way. So here the two type of data structure, these means using these two type of data structure we can enhance our means enhance our program, or we can use a different algorithm to enhance our program, right?
Correct. Yeah, exactly. I just did not take any specific example because we have not yet started the course. That's why I did not take any list or stack or whatever. But yeah, that is the idea.
Yes, sir. Okay. Got it.
Yeah. Anyone else wants to say something? Someone has a because we have not yet started the course. That's why I did not take any list or stack or whatever. But yeah, that is right.
I think someone is watching movie.
Someone, I guess someone on the mic, I guess, and the YouTube is YouTube live is on.
Okay. Okay, so I am on. Sorry, muted. Okay, so that was the idea. So these are data structures and algorithms. All other parts I have discussed. If any doubt is there, you can ask. I mean, there is no other specific doubt in terms of Python or something because it's a recap week. Mostly we would discuss all we just had an overview of how this course would go. Just again, I am stating that fact that please try to write programs from day one. Okay, it would be difficult for those who are doing it for the first time. It would be obviously difficult, but the problem is if you don't practice, things would go very fast. I mean, you have to understand the algorithm, you have to understand the code. We would help you as much as possible in the live sessions, right? We would try our best to discuss it in a very easy to understand from scratch. But the problem is until and unless algorithm you would understand, but until and unless you write code on your own, reading code would not help you. You may think that okay, I understood this line is doing that, this line is doing that, and you end up okay, I would be able to write a code. Just do this fun exercise. When the code comes from, let's say, week 2, week 3, just understand the code. Once you understand the code properly, read it 3-4 times and be super confident that now you understand the code. And then just try to write the same code without seeing it. See the code for 10 times, 20 times after understanding. There is no limitation to that. You can see it in number of times. But once you stop seeing it, I mean, once you start writing the code, then you cannot open the code again to see it. Don't do that. Okay, so you would see that you feel super confident at some stage about understanding the code, but when you go to write it, you would see that okay, this point or how it was happening. That would happen. So there is a fun thing that to do. You can try that out. Okay, so that's why I'm saying until and unless you write code on your own for each of the algorithm, you would not be able to understand the full gist of it. Okay, and when I say write your code, it's not okay. What happened in this case? Just see the code again and try to write it. Not that. You write the same code of the algorithm which has been taught in the lecture itself. Write the same code, but do that on your own. And when you do that, do not see the lecture or the code once again in between. If you are stuck, apply your logic because now you would have already understood the algorithm how it is working. break that algorithm in your mind according to how you would solve the problem. You should know basic Python, right? All of you. So do not, the best way is do not go by the code which is written in the lecture slides as well. Understand the algorithm and then try to break it up in your way, how you would do. So if there is some initialization is there, I don't want to initialize, I understood the algorithm, I would write this line, then I would do this, then I would do this, then I would do this. So assume that you are just solving it on your paper. Okay, so let's say we have some graph algorithm. Okay, so how do you apply that algorithm on paper? You do some writing that, okay, this is shortage, this is addition, subtraction, whatever you are doing. Now, just try to translate your thinking in terms of the code. And if you can do that, it may be a inefficient code or whatever, but if you can do that, and then you go to the code and understand the solution code, right, and write it on your own, then I mean, all graded programming assignment, practice programming assignment would be easy for you. But unless and until you do the programming practice on your own, it would be very difficult. Okay, you don't have to solve 1,000 problems. That's what I'm saying. We would, as a part of this curriculum, we have practice assignment, graded programming assignment. We will do live coding. There are so many coding practices for you. But my first suggestion to you would be, if you are facing difficulty, forget about everything. Just understand the algorithm and write the code algorithm on your own by reading the algorithm 200 times. After that, when you are writing, do it on your own. Once you can write the basic algorithm by understanding each line of it from your mind, then you would see that you are exponentially faster understanding the next questions and all the live codings, all the practice assignment, graded assignment, everything would come in line. But unless and until you understand the core algorithm and you have not written the core algorithm on your own, you would not be able, I mean, how many, let's say 200 solutions to solve a week, you would not be able to, I mean, understand. The 201st problem you would not be able to solve. So write the code of the basic algorithm, the core algorithm on your own from scratch by thinking line by line from your own mind. Once you do that, it should be okay. And please take this thing very seriously. Every term there is this complaint that we are not being able to code. And it's a bit difficult on me because this subject, there are a lot of algorithms that you discuss. And most of the algorithms, I mean, most of the algorithms means most of the broader classification of algorithms. All of them we would discuss in a span of 12 weeks, 11 weeks actually. Not also 11 weeks. The first week is Python recap, so 10 weeks. So it would be a bit difficult to understand the logic and do the coding parallelly. So I would request you to do the coding from day one. That would help you to keep your pace. Okay. And again, the suggestion is write the core algorithm on your own. If you are not being able to keep up with live coding, no problem at all. If you are not being able to keep up with practice assignment, no problem at all. Because anyway, graded assignment you have to do and practice assignment, some bonus marks are there, I think. But those things are fine, but unless and until you are able to code the core algorithm on your own, you would not be able to do other things. So focus on that in the initial weeks. Once you are familiar with all the basic algorithm, then you would feel that, okay, now I can solve the graded assignment very fast. I can solve the live coding also very fast. Okay, so that was just a suggestion. Please adhere to that. Write your code from day one. Oh, any doubts? Any further things? Or
Very nice, sir.
Yeah. Sorry, you want to say something?
Yes.
Yeah, go ahead.
Actually, sir, I am asking about that is in lecture. There is a implement. I mean, Python code. It is a time error. Means object. Time object is that class time error. So, like we have to use this time error object always, or it is like.
No. So that would be taken care from our side. You have to just write your code in an efficient manner. So all the evaluation that would be done, that would be whatever timing constraint is there, that would be taken care of. I mean, the code to check the timing, right? That we would do from our end. But on your own, if you want to practice.
No, it is not required to like remember the things.
No. I mean, obviously you need to understand the data structure and efficiency that we draw out from the algorithms as a part of this course. But whether you have implemented that or not, whether you have implemented the basic code in a normal way, right? So that checking of timing we would do from our end in the exams and all. Yeah, so you don't have to define timer class and use for counter and all those things as part of your code. But obviously, if you want to check on your local system how much faster my code is running, is it okay to submit this?
Oh, but
Then,
okay. If I have to let's say I want to just run my code in my local system, then I have to create this code and save it, right?
if you have to check the timing, then you have to do it. But if you are so that's what I'm saying. If you understand the algorithms and you implement the algorithm and data structure in their required way, then anyway you would get a better timing. So there is no problem, your code would pass. But if you want to confirm about that on your local system, then obviously you would have to write the timing code, right? You have to, I mean, what is it to write? Sir has already discussed the code. You can just copy that.
Yes,
and
yes.
check.
I have the code. I got it. I am just asking that. Okay. Good. Got it.
Okay. So Ashik, you want to say something?
Yeah, sir. Sir, I have a doubt in PPA 2.
Okay.
Yeah, sir. So I've created the class triangle. I've written methods init is valid, site classification and all those. But then for the invalid situation, when the configuration of 3 sites given from us is invalid, then our all other methods should return invalid, right? So I'm using is valid function as a I call is valid function in the definition site classification, but then it shows an error. So is it possible to do so, or am I doing something wrong, or is there any other method?
No, is valid method is only there. Have you taken care of the case, the capital letter, small letter, all those things?
Yeah, sir. Everything I've taken care of. I use is valid as a object, as an object. Yeah, I call it inside a function called site classification. So still it is giving an error. So
okay, so when you are using is valid is itself a part of your triangle class, right? So
yeah.
How you are calling is valid inside site classification?
Yeah. So I call it as if self dot is valid is equal to valid, then go on for the steps, and if it else return invalid itself.
Equal to valid, right?
Yeah, equal to valid, and I call the function is valid, as in I put the braces after that, and I put it as self dot is valid. So
okay,
I guess
then there should not be any problem. There should not be any problem. Just check by calling is valid method whether your is valid is okay or not. Okay, just check whether that is correct or not. Whether you are missing.
So for all other test cases, the output is correct. Only for the case where our sides are not valid, in that it gives an error. So am I allowed to share the screen?
No. You are allowed, but not now. I don't want to.
Okay. So
since the initial week, maybe in the Friday or maybe towards the end of the week. So Friday.
Sure, sir. Then yeah. Okay, then I'll clear, or else I'll try until then.
Yeah. So in the first session, if you have any doubt, so this is how to generally follow it. Any practice question, graded question, we would anyway not discuss, but practice question doubt, I would we all would actually address each doubt, but we should not share the code or anything, because that's what is expected from you. Ask your doubts specifically. We would actually try to solve it. Even on Discourse you can post, we would try to solve it, but the whole code we would not discuss. That's what we want.
Sure. Yes.
Okay, so just check whether your is valid is working properly. So you are using the if else condition in is valid. Check when you are making if condition, you have to return invalid, right? So just check whether when none of the if conditions are followed, are you returning something properly or not? I mean, that case many of us generally miss. If this, return that. If miss, return that. If this, return that. But then we just stop. If nothing happens, then you must return something. Otherwise, the function would actually get trapped. So just check whether you have returned in that case or not. So when none of the
okay, sir. Yeah. I'll check for that as well.
Just check those 2-3 small things out.
Okay, sir.
Sir,
thank you, sir.
Can I ask a question?
Yeah.
Sir, actually, I have done all the PPAs and graded assignment, but in graded assignment one, all the test cases, public and private, those are passing, but without one. Means in private test cases, 4 out of 5 are passing. So I really don't understand like what is that test case? It is not passing or means it is not coming to my mind. So like means how to like debug these problems, like how to do, like how to think, like if I have to, like say right now in graded assignment one, I have one test case is not passing, one private test case. So how to debug, like because as I have done code, it is high, means it is not it is efficient, but I have taken all the possible cases. That's how all of the passing, but remaining one. So how to like think about that?
So how to think about that is something that you would develop when you actually proceed through the course and practice more. There is no specific answer to that, how you can think about the corner cases. And let me mention one other thing. I hope some of you might know how to debug a code. I mean, what do you mean by debugging code? I mean, line by line, you can go through, you can use any IDE, right? And then you put the code in the IDE, and you can line by line see what are the values of each variable when you go through each line. So anyway, we would discuss that when we come to the next week, when the algorithms, basically the program related to algorithms would come. We would discuss that in the session, that how you can actually put the programs in an IDE, and line by line you can iterate through the program. And when you iterate through the program line by line, it's not that you press enter and the result will come. You can do that in a line by line manner. So you press enter, only one line will be executed. Then again press enter, then again next line will be executed. So that line by line execution can be done in an IDE, and that is what we call line by line debugging. So when you do
Yes,
that,
it is available in VS Code, I guess. As
it's available in all of them, and most of the IDE debugging feature is there. Okay, so you can do that, and then you can check what are the status of the variable in the intermediary steps, right? So you can check that what is the status of the variable, all the variables in the intermediary step. As you see the value of the variables in each intermediary step and proceed through the algorithm, then your mind would actually tell you that, okay, this variable is getting this value. What happens if it gets that value? Then my algorithm might not work in that kind of situation. And then you have to back calculate that if this variable is getting this value in this intermediate step, then what should be the input? And in order to get this variable to reach this value. Because I know that when this variable reaches this value, my algorithm would not work. So I would have to back calculate the input. And once you know the input, then you can again modify your algorithm to solve to pass the private case. So that's an abstract way of how, I mean, basically the overview of how you can do that. But you have to debug the code and understand that. And to answer your first question, how to think, there is no specific way. You have to actually do it. Sorry, am I audible? Hello?
Yes, sir.
Okay. Fine. Yeah, Viral, you want to say something?
Yeah, sir. I just wanted to ask about like if there is any book that we should refer to this course.
Books reference are already given, right? You can check the announcement in the course introduction tab. There we have provided that the Corman book is there. It's famously called CLRS, the Introduction to Algorithms by Corman, Stein, Recursion, and I forgot
Yes, sir.
the other authors.
So I was referring to it, but I think it's too big. So is there a way that I should like go on how to read it?
Yeah, obviously. So let's say when we have the week 2, right, release. So now we are only having Python. So when we release the week 2, you see what are the contents that is there in week 2. And if you have the overall syllabus of the basic overview of the syllabus, you can only check those topics. Do not go into the other topics. Just go into those topics in the book and check the topic if you want to. And let's say if a particular topic wants you to understand something as a prerequisite, then only you can go back the prerequisite chain. But otherwise, you don't have to go page by page through the whole book. Only see the algorithm which are there in the syllabus or which are there in the week. Every week we would release, check what are there, which topics are there, and you can refer only those topics. Okay, but the main point which I wanted to focus more is algorithms would be anyway clear to most of you. We would try our best to do that in the sessions and in this course also. But the problem that you would face is programming the thing. And although Python is much easier as compared to C++, as most of you are saying, C++ is a better language to do competitive programming and algorithms. But even Python is easier, but still most of you would face difficulty because of the less time and the other factors. So I would request you to write code. That's why I'm just responding this point again and again. Write code from day one. Okay, maybe don't think about inefficient, efficient. Write code. When we go to the algorithms, see the concept, then obviously it would slowly become efficient day by day. Like the question again, you said how to think about the corner cases. One case is not passing. There is no specific answer to that. I mean, while making questions, we also see all those things, that how to think about the corner cases. Only thing is you can debug it. That is one good tool to actually think of the possibilities where your algorithm might fail. We would show how to debug in the next session, next or maybe next to next session, whenever that is required in an IDE, and maybe you can use that to actually think corners. Okay, and so other book, CLRS is there, first book, and the second book there is one Kleinberg and Tardos, which is also there. Kleinberg and Tardos is, I would say, a little lesser symbolic. That is, if you go to CLRS, it may use a bit more notations. Kleinberg would use a little lesser notations, so to say. So it would be more textual kind of explanations are there in Kleinberg and Tardos. So that would be a bit more easier for the initial stage to understand. Okay, and CLRS would be a bit more notation wise, but you can refer, mix and match these two books. That should be enough. The topics that are there, don't go through the everything. Okay, fine then. If there are any other questions, go ahead. Else we would conclude today's session then. No questions?
So what will we discuss in the next session? Python.
Next question we would next session we would have a live coding. So apparently every open session, this session, the Wednesday session would be a general discussion session where we would do a code walkthrough, maybe discuss the concept. At first we would discuss the concept from detail. You all can ask your questions, your doubts, and then we will also go through the code once, explain the code of the basic algorithms. Yeah, so this session would be, Wednesday session would be discussing concepts and code. Friday session would be on those concepts and code, whichever we discussed in Wednesday session, we would do some problems in live. I mean, there would be 2-3 problems or more than maybe 4 problems at most that would be there, and we would solve together with all of you. You all have also joined the Replit, I hope. So you all would be there, and we would give you some time to solve the problem, and after that we would solve, and you all can follow along. So it should be something like that.
Okay. Some collab.
Yeah, Colab is also there as a way to do the programming, but we would prefer Replit over there.
I got invitation from somebody. 171 persons were there. Whether it is useful to join that collab or not.
71% invitation, I'm not sure about that, but for asking whether Colab itself individually, if it is useful or not, yeah, it is obviously useful, and you can practice your code on Colab.
Okay. It is not compulsory to join that group, right?
I am not aware of any such group. See, the Colab links for the, I'm telling, so the Colab links for the code which has been used in the lectures. Right, where sir is actually doing in Colab, you see that sir is running the program. So those links are given in your supplementary materials. You can go to the Colab links and find those papers, those Colabs. But if it is that link that you are talking about, then that is okay. That is a supplementary content. But any separate Colab, I am not aware of.
Okay.
So
Thank you. I will see. I will see. Thank you, sir. Good night. Good night, everybody. Good night, everybody.
Okay, fine. So no other questions. Is there anyone else? We have some time, 5 minutes.
No, sir. Thank you.
Great. Thank you. Hope all of you would find this subject interesting and interact. We want interaction a lot because that's what is most important in this course. So, okay. All the best and let's meet in
Thank you, sir.
Friday. Thank you.
Thank you, sir.